Hi everyone. Today we are going to deal with the harmonic series. What do you mean by the harmonic series? Okay. In this section, in the series section, we have covered the infinite series definition, some problems, the geometric series definition, and some theorems. Next, we are going to deal with the harmonic series. It is very simple actually. Sigma n equal to 1 to infinity 1 by n. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus etc. This is the harmonic series. Then how can you prove that this is? We have to prove that this series is actually the series is divergent. So we need to prove that this series is divergent. So in order to prove that the series is divergent, we have to look through another technique. That is, we know that the sequence is divergent. If a sequence is convergent, every subsequence is convergent. The sequence is convergent, every subsequence is convergent. So, what about the converse? If all the subsequences are convergent, we can say that the sequence is convergent. But one of these subsequences divergent, we can say that the parent sequence is divergent. Okay, so in order to show that the sequence is divergent, we have to use this technique. That is the subsequence. We have to find out a subsequence which is diverges. Then we can say that the parent sequence means our harmonic series. First of all, we have to create a subsequence of partial sums, and we have to show that that subsequence of partial sums is divergent. Okay, that is the way we are going to do this. Very simple actually. We are going to consider this subsequence of partial sums. Subsequence of partial sums are S2, S4, S8, S16, S2 raised to n, etc. S2 raised to n type of terms we are looked through. Then S2 means 1 plus 1 by 2. S4 is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Right? I can write this as 1 by 2 മാത്രം അവിടെ വെക്കുക ബാക്കിയുള്ള 1 by 3 plus 1 by 4 is greater than. I can write this 1 by 3 is always greater than 1 by 4. So which is equal to, which is greater than 1 by 2 plus 1 by 4 plus 1 by 2, which is 1 plus 2 into 1 by 2. S8 equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8, which is greater than this two ഒരുമിച്ച് എഴുതുക ബാക്കിയുള്ള 4 ഒരുമിച്ച് എഴുതുക 1 by 3 plus 1 by 4 നേരത്തെ അതേ the similar case S4, and this is greater than 1 by 8, 1 by 6 greater than 1 by 8, 1 by 8, 1 by 8. This is 1 plus 3 into 1 by 2. So S8 means S2 raised to 3. Then this is 1 plus 3 into 1 by 2. S4 means S2 raised to 2. That is 1 plus 2 into 1 by 2. S16 is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. That is converted into greater than this term. Again 4 terms. But this is converted into 1 by 8 plus 1 by 8 plus etc. 1 by 8. Next is 8 terms. 1 by 16 plus 1 by 16 plus etc. 8 terms 1 by 16. So this will become 1 by 2, 1 by 2 and 1 by 2. So this is 1 plus 4 into 1 by 2. Finally S2 raised to n is greater than 1 plus n into 1 by 2. So what will happen if n tends to infinity? This term, this right hander tends to infinity, then the left hander must be infinity. So this is subsequence, and this sequence is diverges to infinity. Okay, then we can easily say that this uh, sequence is divergent. Okay, next is the divergent test. Next is the diversion test. Consider this. If the sequence, that is a theorem 2, very important one. If the sequence n equal to 1 to infinity, an converges, then we can say that limit n tends to infinity, an equal to 0. Its nth term tends to 0. If summation n equal to 1 to infinity, an converges, then limit n tends to infinity, an is equal to 0. What about the converse? What about the converse? That is, converse means if the limit n tends to infinity, an equal to 0 implies sigma an converges. Is it true? Then what about the harmonic series? What about the harmonic series? Limit n tends to infinity, 1 by n equal to 0. But we know that the series diverges. The series diverges. Okay. So this converse. So the converse need not be true. Converse need not be true. Then what about the contrapositive in this? Consider the contrapositive one. And here, in the contrapositive one, that means if the limit n tends to infinity, n not equal to 0, then we can say that sigma an diverges. Then we can say that sigma an diverges. If the limit n tends to infinity, an not equal to 0, then we can say that sigma an diverges. There is a contrapositive of this, that is, and this result is also known as the divergent test. Also known as divergent test. In this, you have to look through this proof here. Sn equal to, take the Sn up to this n minus 1th term, this is Sn minus 1 plus an. So an equal to Sn minus 1, right? So limit an equal to limit n tends to infinity Sn minus 1. Limit n tends to infinity Sn minus 1 limit എപ്പോഴും ഒന്ന് തന്നെയായിരിക്കും. ഒരേ സീക്വൻസ് ആണല്ലോ, ഒരേ സീക്വൻസിന്റെ ഏത് ടേം എടുത്തു കഴിഞ്ഞാലും അതിന്റെ ലിമിറ്റ് ഏതിലേക്ക് പോകുള്ളൂ, സെയിം വാല്യൂയിലേക്ക് പോകും. സോ ഇത് s minus s, that's 0 ആയി മാറും. This is very simple actually, you have to look through. Okay, so we have to do the problems related to the divergent test. Show that the following series is divergent. What about that? Sigma n equal to 1 to infinity minus 1 raised to n minus 1. Minus 1 raised to n minus 1. Minus 1 raised to n minus 1. Here an equal to minus 1 raised to n minus 1. And we can say that if n tends to limit n tends to infinity minus 1 raised to n minus 1. N tends to infinity, it plus 1 or minus 1, that will be the value actually, right? So neither it converges, so this does not converges, that is limit does not exist, does not exist. Okay, so if the limit in the divergent test, if the limit tends to infinity a n not equal to 0 or does not exist, then also we can say that is sigma a n diverges. Sigma a n diverges, right? Which implies sigma a n diverges. Next one, next question is a n equal to here 2n square plus 1 divided by 3n square minus 1. Taking n square on both sides, this equal to n square into 2 plus 1 by n square divided by n square into 3 minus 1 by n square. This get cancelled and this is equal to 2 plus 1 by infinity divided by 1 by infinity, which is equal to 2 by 3. Which is equal to 2 by 3. Okay, next we are going to deal with the properties of a convergent series. So that is we can discuss in the next video. Okay, thank you.